Hello everyone, welcome to Logic Medico. Today's interesting topic is the spotter of identification of this baby with a big head. This clinical condition is called as hydrocephalus. Hydro means water, cephalus means it's there within the head. So why this too much water has come within the head? There are so many reasons for that. Either increased production of the CSF or decreased drainage of the CSF. So this condition is called as hydrocephalus. So there are two types of hydrocephalus based on whether there is an obstruction to the flow of CSF. It's called obstructive hydrocephalus, or there is no obstruction, only the production of the CSF is increased. It's called as non-obstructive hydrocephalus. So these are the two types: obstructive, non-obstructive. To understand the obstruction and non-obstruction, I'll just go through this. See this. So the CSF is ultrafiltrate of plasma of the blood within the choroid plexus of the lateral ventricles. These blue color cavities within the cerebral hemisphere is called as lateral ventricles. There are two lateral ventricles, the right and left lateral ventricles within the two cerebral hemisphere. They are interconnected with one another and with the red color cavity, the cavity of diencephalon, called third ventricle, by a Y-shaped foramen called interventricular foramen of Monro. From the third ventricle, the cavity of diencephalon, from there it passes via cerebral aqueduct of Sylvius, that is present as a cavity within the midbrain. It enters behind the brainstem, that is mainly the pons and medulla oblongata, and in front of cerebellum. There is one tent-shaped cavity, green color, depicted in the diagram, called the fourth ventricle. From the fourth ventricle, it has got three options. One, to go down into the central canal of spinal cord, the purple color, you can see. The other option is from the roof of the fourth ventricle through foramen of Megendi, the median foramen of Megendi, M for M, and the lateral foramen of Lashka. There will be two in number, L for L. Lateral foramen of Lashka and median foramen of Megendi. From the roof of the fourth ventricle, it will enter subarachnoid space, that is cerebellomedullary cistern. From the cerebellomedullary cistern, it passes from the subarachnoid space, it passes from the cerebellum to the cerebrum by capillary action, then it reaches this level, the uppermost part of the cerebrum, then finally ends in superior sagittal sinus through arachnoid villi or arachnoid granulation. So what has come from choroid plexus has gone back, that is come from the blood, na? So it has gone back to the blood. It comes through the choroid plexus of the ventricles, it drains into the superior sagittal sinus, which is a venous sinus. So this is how the CSF production, circulation and drainage. So brain is surrounded by a double water bed. The water within the brain, in the ventricles of the brain, and the water around the brain in the subarachnoid space. So there is a shock absorbing function, nutritive function, and also protective function of the CSF. And also there is blood CSF barrier in addition to blood brain barrier. So these are the various roles of the CSF or cerebrospinal fluid. Now imagine there is some obstruction between the two ventricles, interventricular foramen of Monro, or obstruction at cerebral aqueduct of Sylvius, obstruction at the level of this thing, what is it, central canal, obstruction foramen of Megendi and Lashka. So what do you think happens to the CSF circulation? It will get blocked, right? And the cavities will enlarge. So when the cavity starts enlarging from within the brain, so obviously it will press on the brain tissue, resulting in irritability of the child. The child will be having headache, severe headache, vomiting, it will not be able to sleep properly. All these things will happen. Developmental milestones will be delayed. So these are the signs, possible signs which are there in obstructive hydrocephalus. Imagine there is no obstruction, the entire system is open, but still if there is a tsunami of CSF, too much of CSF is coming, that time also these cavities will dilate and cause similar thing. That is called non-obstructive hydrocephalus. Now there are other names for obstructive or non-obstructive. Can you guess what is the name? If there is no obstruction, if imagine this, each of this ventricle, two lateral ventricles, one third ventricle and fourth ventricle, are four rooms in your home. There is no obstruction between them. There is no doors between them, four rooms. Then they are interconnected with one another, right? So they are able to communicate with one another, right? So non-obstructive hydrocephalus is also called as communicating hydrocephalus. Why it's called communicating? Because one cavity is communicating with other without any obstruction. That's the meaning of that. Okay. The other one is obstructive hydrocephalus. The meaning of that is there is some block either in interventricular foramen of Monroe, cerebral aqueduct of Sylvius, foramen of Magen de Lasca, central canal of spinal cord. There is some obstruction. So in one room to other room there is obstruction. There is some door which is preventing that, which is most obvious, right? In most of our homes, some doors are there between the room. So that is called as non-communicating. Why it's called as non-communicating? Because one room is prevented from another room by a door. So we can't communicate directly, right? So obstructive hydrocephalus is also called as non-communicating hydrocephalus. So this is a confusion. Some students think non-communicating and non-obstructing are same. They are actually different. They are reverse. Obstructive is called as non-communicating and communicating is called as non-obstructive. Okay. Kindly be aware of such terms. Okay. Moving on to the last aspect of this water, that is the give to clinical signs. Carefully observe this child. I will tell you the clinical signs. See, there are dilated veins on the scalp. You can see the head as such is enlarged. The head is very much enlarged here. There are engorged veins. We can see the bregma, okay, the anterior fontanelle being elevated, puffed out. Okay, the child is having a huge head when compared to the facial skeleton. You can see the eyes are sinking down. It's called a sunset sign. Okay, and the baby will be irritable. Severe headache will be there for the child. Sad. And then vomiting will be there. Developmental milestone, that is, the child will not be able to turn over in the cradle. It will not be able to creep or crawl because of the huge head. The delayed milestones will be there. You kindly check out the other milestones are there. I will put the link in the I button. You can check out developmental milestones in different age group. That is all delayed here in this child. So these are the various signs which are there. I'll just summarize. Irritability and vomiting. It is due to increased intracranial tension because of increased CSF. Enlargement of the head because of dilated cavities of the ventricles. Sunset sign, that is the eyes sinking down, facing downwards. That's called sunset sign. Cracked pot, that is the head appears like a cracked pot. It's very huge head and cracked pot. Transillumination test is positive. That is, if you throw a light on the head, it is transilluminate. That shows that there is a clear transparent fluid, which is nothing but CSF. And sutural diastasis, meaning the sutures are separated and they are wide apart. So it's called sutural diastasis. Usually by 2 years of age, all sutures, all the fontanelle should fuse, but here the sutures are opened up. That's the meaning of sutural